All right, so let's try to finish this up. It seems like it's been a while since we did the first part of this, the part A. But this is really quite a bit different than that minutes and seconds and degrees and that kind of stuff. So the first word that we're going to talk about is coterminal. Coterminal. Okay, we're going to specifically talk about coterminal angles. All right. So let's tell you what. Let me just grab one that's already made, an x and y axis, because we'll be using this a little bit. So I'll copy that. Put that right there. All right. All right, so here we go. Let me make... Oh. I was wondering, my notes started like halfway through because I didn't have the first paper up there. All right, let's talk about, I tell you what, let's put coterminal on hold. We'll do that in a minute. And we're going to talk about this. Quadrantal. It's a weird word. Quadrantal angles. Quadrantal is probably how I would say that. Quadrantal angles. We talked a little bit, yes, was it yesterday where I touched on this a little bit? Yeah, but I did some of this XY axis stuff though yesterday, didn't I? Yeah. So what did I say this angle was right here? This would be in standard form, okay? If I'm going to the positive right, to the positive x-axis, what degree do I start at? It's 0 degrees. So that's 0 degrees. And to go the traditional way, all right, I don't know, I guess they got a name for it. If I go in this direction right here, which is counterclockwise, okay, this is the way our standard, that's the word I was thinking of. Okay, this is our standard way of measuring angles. We start from the positive x-axis, which is 0 degrees, and then we go in this direction. So how many degrees do you think it is going up here, the positive y-axis? If I go up to here, how many degrees is that? It's 90 degrees. It's a 90-degree angle, isn't it? All right, so this would be 90 degrees. Again, if I'm starting here, I'm starting from my, let's see, do you have a word? See, some of these words you don't use until, like, you teach them at first, and then you don't say those words that often. Let me see if I have a word I want to use. We'll just say it's in standard position, okay? So this is standard position to the 0 degrees. That would be 90 degrees. If I start here and then go all the way around to here, how many degrees is that? That would be 180, wouldn't it? Because a 90 and a 90. Everybody got that? Yeah, pretty easy. And if I go all the way down to here to the negative y-axis, that's 90, that's 90, that's 90. What is that? How about 270? Okay, 3 90s. Okay, 3 times 9 is 27. So 270 degrees. Okay, so if I started here at 0 and I go all the way to here, counterclockwise, that's 270 degrees. Now, Sam, if I go all the way back to here, I'm also at 360. Okay, so which ones are the quadrantal angles? The ones that I marked, okay? 90 degrees is one, 180 is another, 270 is another. You could, I guess, consider 0 as one, or 360, okay? Everything's divisible by 90, isn't it? All right, so quad meaning 4, correct? There's 1, 2, 3, 4 quadrants in here, and so these are the ones that make up those quadrants. So 90, 180, 270. It's pretty easy, isn't it? Yeah. You could go the other way. Our standard way is to go counterclockwise. Another way you could do it, you could go the opposite way. So you could go this direction. So this is 270, like I said before, but you could also write it as what else? If I go in the other direction, I'm going the negative direction, right? I didn't say that, but if you're going in the opposite direction, you're going negative. So this is positive 270, or you could write it as what? Negative 90. Good. All right. And if you go, again, from that 0 degree, from that standard position, and you go to here, positive 180 means it tells you the direction you are going, and it tells you how many degrees that you went, okay? The positive 180. If I went this way with the yellow one, where else could this be? that's also negative 180. Okay? So you're like, well, how's that positive and negative? Well, it all depends on the direction. Okay? The positive and negative means which direction are you going. If it's negative, you're going in this direction, clockwise. All right? If it's a positive angle, then you're going in this direction, which is counterclockwise. Everybody got that? And let's keep going. If you go to there, what's that? The yellow? Right, this would be negative 270. It would also be positive 90. It's at the same spot, isn't it? I'm at the same exact angle. I'm at the same spot right here. But look how far I went. I went 270 degrees in the opposite direction, so it's negative 270. And of course, I could end up where I started. So I could call it positive 360, or I could call it what? Negative 360. All right? Again, the negative just means you started here and you went underneath and then back over again. Okay? You went clockwise. Make sense? Yeah. And that's pretty important. Let me just double check something here. All right. Let's see. All right. You could also do this. Let's not jumble this up. It's already messed up a lot. So let's do this again. Let's go different color. You could also do this. Let's say, all right, let's just do the example. I think that might be the easiest way to do it. So example 2. Is it example 2? Looks like I wrote example, I don't know, maybe the other one was example 1, and I put it 2. Anyway, I'll write example 2. It's probably in the book somewhere. It says, give the angle measure represented by each rotation. So part A says, give the angle measure represented by 5.5 rotations. We'll talk about this. Rotations clockwise. Again, the direction that you go will change your answer. All right? When I say rotations, what does that mean? If I go 1 rotation, how many degrees is that? 360. If I go 2 rotations, that's 720. You get it? If I go 3 rotations, it's 3 times 360, which is whatever it is, 1,080, 1080. Yeah, that's probably right. You with me on that? So, let's get rid of that. If I go 5, forget the 0.5 right now, okay? If I go 5 rotations, I'm going once, twice, 3, 4, 5. I'm basically ending up right here, correct? So really, does the 5 really make any difference? Actually, I'm going clockwise, aren't I? Sorry. I'm going the other way. Forgot that. Okay, I'm going this way. But does that really make any difference? Not really, okay? Once, twice, 3 times, 4 times, 5 times. But then I got to do that half. So really, I'm here. I went around 5 times, okay? I'm getting dizzy, right? 1, 2, 3, 4, 5. So I'm back where I started. And then I got to go another half rotation clockwise. So where does that put me? That puts me right there, going in this direction. So that puts me at where? Negative 180. But did I only go 180 degrees? No, I went 5 times what? 360 plus, okay, half of 360 if you wanted to do that, right? Would you agree with that? Okay, I could have just gone 5.5 times 360, but this kind of makes you understand what you're doing, all right? So I went the 5 times, and then you put all that in your calculator, and again, it's in the negative direction because of the clockwise, so what's my answer going to be? Negative, whatever that is, and that's 1980 degrees, 1,980 degrees. Again, you could have just put 5.5 times 360. I just wanted to show you that this basically gets you to the same spot where you started in the first place, but you've already gone around 5 times, right? And then you go halfway, and that's negative 180. That's the half of 360, right? Everybody see that? All right, but you put it all in there and you get negative that. All right, we'll do this one, part B. I won't even have to draw it for you. You should probably figure it out. What if it says, what's the angle measure represented by 3.3 rotations This time we're going counterclockwise. Counter. So is your answer going to be a positive or a negative? How do you know? Just because of what? The counterclockwise. That's right. So when they tell you counterclockwise, it means it's going to be positive. All right. So really, what are you just doing right here? What math are you doing? Well, you could, again, let's do it the easier way. This was a little bit more drawn out. Remember I said you could have gone 5.5 times 360. It's going to give you the same thing. So what's the easiest way to do this? It's just 3.3 times what? 360. Okay, and that gives you, I already did the math, it's 1188. Okay, so you might see a couple problems, handful of problems like that. That's pretty easy, isn't it? Well, that problem's like that. Okay, but there are other problems that are probably more difficult than that, yes. Okay? I don't know if it gets much, yeah, I guess it could get a little more difficult. All right, let's talk about this word. What was that word that I wrote down earlier? Coterminal. So let's write that down. Now we're ready to talk about that. Oops. Coterminal. Okay, where do I want to go? Let's do this. Let's put that in there again. And we've kind of talked a little bit about it already, but let's do some more. Let's change colors. Let's make this a little thicker because I want it to show up right here. So what we're going to do is I'm going to draw an angle, an actual angle, all right? And I'm going to draw it along this axis, all right? You can go all the way out here. You could go here, go here. It doesn't matter. The arrow just means it keeps on going. Is that all right? I'll just draw it to there, all right? Everybody see that? So there's one side of my angle, all right? Now this first one's a little weirder. The other ones make more sense, I think. This one right here starts here and it goes right to there. Okay, so there's two sides. How many degrees in between those two sides of that angle? If I got one side right here and another side right here, okay, 0 degrees, right? Okay, see, that would be 90 degrees, right? That would be 45 degrees. That would be 30 degrees. If it's like this, right on top of each other, how many degrees is that? That's 0 degrees, all right? So basically what it's saying is this. It's saying that that's 0 degrees, all right? I made that 2 points. That's really thick. Let's try this. Now, I'm going to try something. I don't know if I can do this or not, but let's try it. Oops, I think I grabbed the red. Trying to grab the blue one. Come on. Come on. It looks like it should click, doesn't it? Well, it's clicking the red one. Don't know why. All right. But that's all right. I'll use the red one. All right. So let's say I split the difference and I go right here. So what's that angle? It'd be 45 degrees, wouldn't it? Then up to here is 90, right? I could keep doing that. See, there's 45, there's 90, there's 180, there's 270, and that kind of thing right there. So what if this thing went around like one full rotation? It's kind of talking about what we just finished talking about. What would that give us? That would give us what? 360, okay? So you could keep going, couldn't you? If you went around another rotation, what would it be? 720. Went around another rotation, what'd you say it was, Sam? 1080? Okay? And you could just keep doing that all day long, couldn't you? All right? So any angle, all right, that if you go around one time and it stops at the same spot, okay, those are considered coterminal. So, for instance, let's do this. I'm just trying to, it didn't work. Come on. That's what I'm trying to do. All right, so what if you had an angle like that? Now I'm trying to grab that blue one. Why is it not grabbing? Maybe because it went behind. So let me do this like that. Aha, there it is. Okay? It was hiding from me. So what if you had an angle? Let's say it was at 45 degrees, okay? And if I took, oops, I was doing so well. There we go. If I went around one full circle back to here again, then they would be coterminal angles. So what would the first one be? The first one would be 45 degrees. What would the next one, if I went all the way around the circle, what would that be? It'd be 360 plus 45, which is 405. Is that right? Yep. So 405. These would be considered what? Coterminal angles. All right? Everybody got it? So they're different numbers, but they really are pointing in the same direction. All right, if you want to say it that way. We got that? Yeah. So how would I find like all the coterminal angles? Let's come up with a little formula for it. Okay? So what if that angle was 45 degrees to begin with? Why is that still so big? Let me change that. I thought I fixed it. No, it's because I made it 2 point instead of 1 point. All right, now it's 1 point. So what would that be? That'd be 45 degrees. How did I get the 405? What did I do to that 45? I added what? I added 360. Okay? And what if I went around twice? How would I find the coterminal angle? Like the next one after 405? Times 2, that's right. And if I went it 3 times around, times 3. But still, you got to add that 45 to it. Does that make sense? So all that is doing, let's say I go around 3 times. What does this tell me? This tells me I go around 3 rotations plus that 45. All right? So here's what you do. A coterminal, they use, I think we talked about this the other day, they use the letter alpha. Okay, it's a Greek letter of the alphabet. All right, kind of looks like that. That's how I draw it anyway. If you look in the book, it looks kind of like that. All right, you just do your own alpha, okay? That's how I do alpha. So for whatever reason, they use alpha, and they say, how do you find an angle that's coterminal with alpha? Well, you take that angle, so my alpha in this case is the 45, right? Plus what? 360 times how many rotations? They choose the letter K, don't know why, they just do. They use the letter K to represent how many rotations. So when you see this, this is how you find any angle that's coterminal with alpha. All right? You start off with the angle. So like right here, you started off with 0, correct? So 0 plus 360. This one would be what? 0 plus 360 times 2. This would be 0 plus 360 times 3. Does that make sense? So this K tells you how many what? Rotations. The alpha is basically your starting angle, okay? Let's just say that. There's probably a better word for it, but let's just say that. That's your starting angle. And of course, the 360 just means you go around the circle one time. All right. Sounds like we're kind of beating a dead horse here. We've been talking about this over and over again. So what we are going to do is look at example 3, and we've talked about it enough. Let's just do a problem, and you might have this on that homework that you're working on. So it says, I'm not going to write the whole entire instructions. It's very long. It would just take me the rest of the class to write the instructions. I'll read it though. It says, identify all angles that are coterminal with each angle. So they give you a couple angles. There's more to it. All right. So part A, they give you 45 degrees, and part B, they give you 225 degrees. All right. And they say, identify all the angles that are coterminal with each angle, with these 2 angles right here. Find one positive angle and one negative angle that are coterminal with the angle. All right? It's a lot of words, right? That's why I didn't write it all down. So what are they asking you to do? They're finding a positive, because what are we doing? We're starting at 45, right? And we want to go around this way, right? And we want to be able to go an infinite number of times around. Okay? That's why we did that little formula earlier. But then I want to do a negative. So I want to go around this way a bunch of times. All right? That's kind of what we're doing. So let's do it. if I start at 45, what are all the angles, all of them, that are coterminal with 45? Well, if I go around one 360, that's one coterminal. If I go around two 360s, that's two of them. You with me? If I go 3, 4, 5, how do I do that? Plus what? 360 times k. That's it. All right? You with me? It says find one positive and one negative. All right, so I could go 57 times around the circle, but that would be ridiculous. That'd be dumb, wouldn't it? I wouldn't want to do that. So what could I do? Let's just go around one rotation. Let's say one rotation. So what would that be? We already did it. It's 45 plus 360 times 1, which is 360, and that's 405. So that's one positive coterminal angle with 45 degrees. I could have put a 2 in for this. I could have made that 720 and gone 720 plus 45 and got an angle. That would work too. All right? There's not just one answer. Unless they specify, keep it between, one number and another number, okay? So that's one answer for that. That's the positive direction. What about the negative direction? What do you think I'm going to do? I'm going to start at 45 degrees and then go what? 360 times, right. If I wanted to go just one time, I could just go -1. You see that? That negative just tells me I'm going to go in the clockwise direction instead of the counterclockwise direction. And so what do you end up basically doing? 45 what? Minus 360, exactly. All right? And if you wanted to go 2 times, 3 times, 4 times, you could put that number in here as well. They don't give you any restrictions for how many times you want to go around the circle. You could pick once, twice, 3, 4, 10, 15, 100 times. All right? And then you just get that, which is what? Negative, what's that, 315? I picked a different number than 1, so I didn't do this one. I think that's negative 315. I picked 2, all right? I think the book did pick 2. But it's the same, it's fine. Either one of those is fine because it doesn't say how many times they want you to go around the circle. You can go around the circle as many times you want. All right, but that's how you do it. You add 360 times how many times you're going around the circle, or you basically subtract 360 times how many times you're going around the circle. We good? Let's do this with 225. So what would you do with this one? Start with 225 and then do what? Plus. Now the book does, I don't know why, they just chose it just to be contrary, I guess. They want you to go around 2 times around the circle, okay? So if I was going to go 2 times around the circle, 2 rotations, where am I going to end up? I'm going to go plus 360 times what? Times 2, that's right. And you do the math and you get 945. You could have gone just 1 time around the circle if you wanted to. You could have gone 3 times around the circle. You're still going to end up in the same place. 225 is in the same place as 945. All right? Does that make sense? All right? And then one more. Let's go negative. For some reason, they go just 1 time around the circle, but they go in the opposite direction. So what is that? Starting off at 225, and then what can you do? Just minus 360. We went 1 time around the circle, so you put a 1. Or you could have put plus and a negative right there. It wouldn't make any difference. And then whatever that is, it's negative 135 degrees. So that's how you do those. All right? We're almost done. The next example, they do give you a restriction. Remember on that one, you could go once around, twice around, 3 times around, it doesn't matter. But this next problem, example 4, they do restrict you. All right, so if you look at example 4 in the book, again, it's too long. That's a 4. It's too long to write down. I'm just going to read it. It says, if each angle is in standard position, determine a coterminal angle that is between 0 and 360. So we're not going any more times around than once, okay? We're just going to go around 1 time. And it says, state the quadrant in which the terminal side lies. I think that's the one you were asking about, wasn't it? It sounds like the problem that you said you didn't know how to do. All right, so here we go. So we've got this, And it starts off, so it's a little different than what we've been doing. So they give you the big degrees, okay? So 775, that means I go around 360, go around another 360, keep on going, all right? But I want it within just one time around the circle. So you could do this a couple ways. Here's how I would do it. I think it's kind of easier to do it like this. 775. I got to keep it within 0 to 360. So what am I going to do with that 775? I'm going to subtract a 360 from it. Because if I do, I'm still pointing in the same direction, correct? I just went one less time around the circle, all right? And so you get 415. This still doesn't lie between 0 and 360. So what am I going to do to this now? I'm going to take away another what? 360. That's right. Take away another 360 degrees, and you get 55 degrees. So watch. 55 degrees is something like this. Okay, that's 55 degrees. That angle right there is the same angle as 415 and the same angle as what? 775. Everybody see that? So if you have a really big angle that goes more than 360, what do you do to find the coterminal angle? You just keep subtracting 360 from it, right? I mean, 415 is coterminal with 775, but it's not between 0 and 360, all right? So we're not going to use that one. So what do I got to do? I got to take 360 away again, all right, to get that. They give you two of those. If you go the other direction, instead of taking away 360, what are you going to do? If that was negative 775, you would add a 360, all right, and then come up with that. Then if you still are not in between 0 and 360, then you add another 360, okay? One more, and we'll be done. We've got 3 minutes just in time. All right, so here we got this thing again. The question says a reference angle. Reference. All right, so they're going to give you, they start off, they start off with an angle this way. Click off of that, and then an angle this way, like that. Okay? And basically, the reference angle that they're referring to is the angle that's formed with the x-axis. So if this was 120 degrees, the reference angle is going to be this angle right here. You see it? It's the angle that it makes with 180 degrees, with a straight line. So if that's 120, what's your reference angle then? What would this yellow angle be? It'd be 60 degrees, exactly. All right? And you could do it the opposite way as well, right? You could go the other way, and that's basically the same thing. So that would be a reference angle, okay? The angle that it forms with 180 degrees. And that's it. So now you should be prepared to do all these problems. What did I give you? 19 to 57 odds? All right, so you should be able to get those done. And you've probably done a few of these already, haven't you? All right, so you probably don't have to do all of these tonight. But if you haven't touched them, you will have to do all of them tonight. All right, so for the reference angle? Oh, it says, it's right, because it's got to be between, yeah, you just keep adding 360s until you get a positive angle that's between 0 and 360. Yeah, good point, good point. Now, it also says what terminal does, or what quadrant does it lie in, all right? I mean, you could figure that out. If you know what angle it is, you know the first, second, third, fourth quadrants, right? First, second, third, fourth. Yeah, that shouldn't be a big deal to you. All right, so this is section 5.1. I don't think there's an A or B to this, right? So it's just that. And that's due tomorrow. Okay, and then tomorrow, finally, we will do some real trig. But this kind of leads us up to it, to what we're doing. All right, so this stuff is important for what we're going to do. So we will do that tomorrow. And what we're going to do tomorrow is basically, the one lesson is like what we did in geometry. All right, so, but then it becomes different.